Okay, so this is number 12 from your review on page 193. And so what I'm going to do here is, like, if you read, to solve each equation using technology. So what I'm going to do is actually just solve this with Desmos first, and then I'll explain to you how on earth it's possible that we got those answers with the algebra. Because ultimately in the test, for an equality, I'm not going to have technology for you to solve those. So what I'm going to do is actually show you visually with Desmos, and then I'll algebraically show you the solution to get to those answers. So essentially what's happening here, and I think like in this video, I think we'll articulate exactly what's happening here better than we did in class, kind of thing. But it wants us to basically find the point of intersection. So if you guys think about in the past, you've done some stuff with like y equals 3x plus 5 and y equals negative 2x minus 4. Said find the POE or something like that, right? So to do that, you would have said 3x plus 5 is equal to negative 2x minus 4. And you would have solved for x, plugged x into y, and found that stuff, right? So, or plugged it back into one of the equations, sorry. So what we're going to do is basically that. There's just, you don't have linear functions anymore. You've got two rational functions. Okay, and so what we're going to do is the same work. They've already been like equated. And so I'm just going to try and solve for the values of x that satisfy these two equations being equal. Okay, and so the first way we're going to do that is I'm just going to throw it into Desmos and we're going to see what happens, okay? So I'm going to put 4x over x plus 2. Okay, so that gives you one of the graphs. And then I'm going to plot the other side, 5x over 3x plus 1. Okay, and then you're going to see on the left side of the vertical asymptote, the green graph is getting closer to the vertical asymptote at a different rate than the purple graph, right? And so they're never actually going to touch. They're both getting closer and closer. They're just like, they're far apart, right? And moving at a different rate. So they're never going to cross over on the left side. However, if you zoom in, you can see that they do cross somewhere, and in particular, two spots. So if it was interesting to see, so if I can do this quickly on the iPad, I don't know if I'm going to be able to do it. It won't let me equate them. But if I get 4x over x plus 2 equals 5x over 3x plus 1. Get these two vertical lines spit out, and they actually just show where those two graphs are going to be equal. Okay, so those are basically our answers for the problem. And now we're going to jump back over to the actual question, and I'm going to run through the algebra to get to those two answers. Okay, I'll leave those up. And so what we're going to do is try and solve these things. And they're very similar in the sense that, like, to the inequalities. So you can do this one of two ways. And I think there's an easy way and a more difficult way. With the equalities, remember, we can cross multiply and solve. So we can do this one of two ways. We can go 4x over x plus 2 minus 5x over 3x plus 1. That has to equal 0. So we can do that. That's fine. I think that's then going to require us to do some common denominators and whatnot. So I'm going to maybe avoid doing that. And alternatively, I'm just going to cross multiply. Okay, so I'm going to go 4x. So remember, if I just cross multiply, it means this. Not a great color, but 4x multiplied by 3x plus 1 is equal to 5x times x plus 2. Okay, and then I can distribute on both, and I'd have 12x squared plus 4x is equal to 5x squared plus 10x. Okay, I can bring the 5x squared over. Okay, we'll bring both of them over. I'm going to get 12x squared minus 5x squared plus 4x minus 10x has to equal 0. Okay, and then 12x squared minus 5x squared is going to be 7x squared. And then 4x minus 10x is going to be minus 6x. It's going to equal 0. So what I can do here to solve, remember, we're just solving this. We're going to go factor an x out. So I'm going to get x times 7x minus 6. It's going to equal 0. Okay, and then so x can equal 0, and 7x minus 6 can equal 0, and so 7x is going to equal 6, and x is going to be 6 by 7. Now, if I go back over to Desmos here, I have a sneaky suspicion that 6 divided by 7 is going to be 0.857. So let's look. There you go. So we got it right. So 6 divided by 7 is at 0.857. If we wanted to solve for the x-intercept, or like the actual points of intersection, which is what we started this problem by saying, right? So points of intersection. We could then say, well, if I put in 0 for x into either of those two equations, so if I evaluate, so if this one's f of x and this one's g of x, we've found the x values where f of x is equal to g of x. That's what we've just found. This is true at x is equal to 0 and x is equal to 6 by 7. Now, to solve for the points of it, the actual points of intersection, we could actually just go pick one of f of x or g of x and just evaluate the function at 0, right? So I'm going to get 4 times 0 over 0 plus 2, right? Which is then going to be f at 0 is going to be 0 by 2, which is f at 0 is equal to 0. So that's one of our points of intersection. That's this one over here, okay? And we need the other one to be 1.2. So I could actually find f at, where did it go? 6 by 7. Okay, so we can go, this is going to be a little bit more detailed. 5. Again, you could pick, actually, you could pick the f of x, sorry, I picked g of x here. Okay, and if you ran through that, you would end up getting 1.2. Okay, so there you go. There's the algebra that matches the graphical representation. The algebra is what we're going to actually ask you to do during the test because we don't have access to the Desmos. So there you go.